Hello, everyone. Thank you for joining this webinar. My name is Isam Esper. I'm a field application engineer with the support team of Electro Industries. Today's webinar would be covering the basic programming of the Nexus 1450 power energy meter. Before starting, let me give you a very quick overview about the Nexus 1450. As you can see in this picture here, the Nexus 1450, it's a high power quality industrial meter. It has multi-communication ports. As you can see here, it has 4 serial communication ports. The first one can be switched between an RS-232 and RS-485, and the other 3 serial ports are RS-485 ports. It has also port 5, which is an Ethernet RJ45 normal copper connector. And it has also port 6, which is the Ethernet fiber optic port. So this meter can has 2 separate IP addresses at these 2 ports. It comes also with the digital inputs, 8 digital inputs and 2 pulse outputs and Eric-B. The Nexus 1450 is a cyber secure meter. It can do a waveform capture up to 1024 samples per cycle. So to do the programming for the Nexus 1450, we are using the Communicator software. It's a free software, can be downloaded from our website. The new version, it's called CommunicatorPQA. You may be using the previous version, which is Communicator EXT. It was Communicator EXT version 4. On the website at electroind.com, you can find, if you go to product, you will be able to see the Nexus 1450. And from there, you can download the technical documents and all the user manuals from here. And also from the same products page, if you scroll down, you can find the communicator where you can download the free version from here. So going back to the communicator, we would start by connecting with the meter. To do the connect, we have the connect icon here. I will click on this. And as you can see, we have 2 options. So the serial port would be used when we are connecting to the Nexus 1450 using any of the serial ports, either the RS-232 or the RS-485. These settings should be matched with the port setting itself. So the device address, which can be a number between 1 and 247, by default, the device addresses would be 1 for all the communication ports. And then we have the baud rate, which can be any of these baud rates. And again, the default is 57600. Then we have this option where we can hit available ports. The available ports will give you what's connected to your USB, to your laptop. As you can see here, it's telling me that I have a USB serial cable connected to port COM3. And then the protocol, which is Modbus RTU, and the other options, which would be matching with the port settings. So we have the flow control none, the echo mode is no echo, and the parity is none. I will hit connect. And once I'm connected, the device status window will pop up like this. So on the device status window, on the left side, we will be looking at device, which is the meter's name. And this is something we can configure on the profile. We will talk about this later. And then we have the device type, which is the model, and the serial number. And on the right side, we will see the firmware information, like this is the version of the firmware, and the V switch of the meter. And it tells us about the status of the meter, like you can see here. It has a healthy COM state, healthy DSP state, and the password is disabled. So I will hit OK and disconnect to show you how we can connect using the Ethernet port or the network port. So I will hit connect and choose network. And from here, we have the device address, which is also by default 1. And the host would be the device or the meter's IP address. The default IP addresses for our meters would be either 10.0.0.1 or 10.0.0.2, depends on the model. But my meter now has an IP address 10.0.0.14. The network port by default is 502. And the protocol, of course, for the network should be Modbus TCP. I would like to mention one more thing before connecting with the meter, that when you are using the network port, and let's say that you are connected directly with the meter, not through the network, you have to make sure that your IP address is set on the same IP address range or IP address domain. So for example, you can go to your network settings and find your Ethernet adapter options. This is like in Windows 10. In Windows 7, it could be called LAN, local area connection. So I would go to my adapter here, and I would find the Ethernet adapter I'm using, hit properties, and go to Internet Protocol version 4 TCP IP v4. And I would set my IP address or my laptop IP address to be on the same IP address range, like I'm setting here this for 10.0.0.6. And no need for the default gateway when we are connected directly with the meter. So going back to the communicator, using the connect icon here. And I would get the same device status window once I connect to the meter. So that's all about how we can connect for the Nexus 1450. Now we will talk about how we can do the basic programming and the default profile, and how we can do the CT-PT ratios and all the basic programming of the 1450. After we get connected with the meter, we will go to profile here. And after we got the device profile window pop up like this, we have the model here and the vSwitch. And on the tree menu, we will go to the general settings. Under the general settings, we have CT-PT ratios and system hookup. It's a one window for all of these, so I can choose any of them. And this is where we set the CT ratio. So let's say that this meter would be installed in a panel or a switch gear using a CT size 800:5. So I would set the primary for 800 and the secondary as a 5. And this meter also gives you the option to have a CT on the neutral current also. So if you have that, you can set it also here on IN. Then we have the PT ratio, and the same idea. We would set the PT ratio based on the PT size we are using. But if we are not using any PTs there, it's very important also to set the PT ratio correctly based on the system voltage. So for example, if we are using the meter at a 208, 120 system, so we will set the ratio to be 120, 120. We are using the line to neutral voltage. But if it's at 480, 277, I will set this to 277 and the secondary also 277. So the ratio would be still 1, like if we do it like this, or 120, 120. And this is not going to affect the power and the energy reading. But it's very important to set the PT ratio according to the system voltage, because we have the limits and the alarm settings in this meter. And that limits and alarm would be a percentage of the full scale value. And that full scale value would be taken from this number. We will show that later. So I will set back to 120, 120. And similar to that, we have also a fourth voltage input where we can have another source of voltage there. We can set the PT ratio for that at the V auxiliary. Then we have the system wiring, where we can choose between Y or delta or 2.5 elements, depends on the system there. And we have the volt amp and the volt amp hour computing method, which can be either the vector sum or the arithmetic sum. Then we have the frequency range. The default one would be 50, 60 hertz, and the other option would be the wideband auto. And this is a frequency range between 20 and 500. Once we set everything here, we will hit OK. And once we hit OK, we will get this message showing us or telling us that we did some changes, and that means the limit and the full scale value gonna be affected. So do you want to verify that? We will hit OK, and we will get the other window showing the limit and the waveform full scales. So as you can see, the current full scale is now 800 based on that CT ratio, and the voltage is 120, 208 based on that PT ratio, and then we have the power and the frequency. I will hit OK since everything is fine, and we will jump to the next window. So the next one is the one we did, the limit and the waveform full scale. We are done with this. Then we have the time settings. On the time settings, we will set the time zone where based on where the meter would be installed. Like by default, it would be -5. This is the Eastern time. And we can change that if the meter installed in different location. Then we have the option to enable the daylight saving time. So we either choose the auto DST, or we have the custom where we can set the dates for the daylight saving time, when it starts and when it's end. And when we have also the synchronization option, where we can choose to, if we have the meter connected to a network and we have the network time protocol, so we can choose that. And if we choose that, we have to configure that by choosing which port is used to connect to that network. We will talk about this in more details when we talk about the communication ports. If we don't have that option, we can choose the line sync 60 Hertz and hit OK. The next section would be the labels. And under the labels, this is where we can give the name for the meter. As you can see, we have the meter designation, and this was the name we saw when we connect with the meter. So we can give a different name from here. And we can give a label for the voltage auxiliary and for the neutral current. The power direction, this is where we can change the labels for the energy. Like by default, it would be considered as quadrant 1 plus 4 is the delivered, and 2 and 3 is the received. We can choose the reverse type. And this is all about labeling. That is the delivered, is the energy delivered to the customer, or is it received? Most of the time, when the meter installed at the customer side, we will consider that delivered energy to the customer. When we are using the meter, the generator, for example, we would be looking at a received energy from the generator. And the same also, we have a power factor display where we have method 1 and method 2, and that will give you either the sine wave for the power factor or the 4 segments in the different quadrants. Then we will hit OK and go to the communications. Under the communications, it's a one window also for all of that. So we can double click, and from here we can set the communication port settings. So you can see that the serial port 1, 2, 3, 4, and it can have a different address, different baud rates, and all the other settings, and the protocol also. Because the port 3 and port 4 can be used to connect with input-output modules, so we have this option here to choose between a master input-output module or a slave. If it's slave, it can be used to connect with the display or just to connect with the meter. On the same page also, we have the port 5 and 6 also, which is the Ethernet settings. So we can set the IP address for port 5 and the subnet mask, and the same for the port 6, which is the IP address over the fiber optic. And we have also the advanced settings here for these 2 ports. So if we hit this one, this is where we can enable and disable the services for the port 5 and 6. As you can see here, the web page is enabled for both port 5 and 6. So we can choose one of them only, or we can disable that. And we can set the port for each one of them. And the same for the Modbus TCP. We can disable or choose one port or enable both ports. And we have also the option to enable one of the ports to talk on the GE protocol, the DMP, and the SMTP. And if we enable that, we will get the tab is also active. Like for example, the SNTP now is inactive. If we enable it for port 5, we will get the alarm and email now active, where we can set an alarm and email. If we go back to the service and disable it, so you will see that it's disabled now. And we talked about the network time synchronization. Also, we can also enable it from here for port 5 or port 6, or for auto, which can be any of them. And once we enable it here, we can see that the tab is active here. After the communications, we have the DMP custom class. If you are using the DMP protocol, this is where you can configure the DMP map. So you have all the objects here, and you can add all the points by adding the line and the point from here. So like, for example, object 1, object 10, object 30. So all that you have to do is just add the numbers here, and you will get the description for that point. We have also the configure high speed, and this is how you can set the high speed update rate. It should be a number between 2 and 20 cycles, and by default, it would be set for 6 cycles. After the general settings, we have the revenue and energy settings. This is where we can set the energy scaling. If I click on this one, you would see that we have all the different kind of energy types. And this is where we can set how many digits we want to use for that accumulator. Like for example, the default one is 8 digits, and there is 2 after the decimal. And the unit, is it kilo or mega or just a unit? And according to what we choose here, the example would tell us how it would be looking like. Like for example, if I choose 9, just 1 after the decimal, and mega, we would be looking at like this accumulator. And this will tell us like when it would be rollover. So based on the load also, you can choose if you want to use the kilo or the mega, if you know that you have a big load there. And if you use the kilo and that would be rolling over very fast, you can go with the megawatt. And the same thing for the other energy tabs also. The demand integration interval, this is where we can set what kind of demand, like by going to the block window here, and we can choose between the block or the rolling. And we can set also the interval, like is it every 15 minutes or 10 minutes, and the sub interval for the how many for the rolling only. Like if it's block, there will not be that option. We have also the thermal average, where we can set also the interval window for the thermal average, and how long would be the max and the minimum thermal average block interval also. We have the option to reset, so we can perform a time of use read on the maximum demand reset. We can enable it from here. The internal pulse, because this meter has 2 pulse outputs, and it has 2 test pulses, which can be used to test the meter. So this is where we can set up these test pulses, and we can choose one of these quadrant energy, and we can give the weight for that pulse. Like by default, it would be 1.8 watt-hour per pulse, but that can be changed, and we can set the pulse width based on the tester we are using. And we can choose between form A and form C. We have also this option where we can enable the transformer line and loss compensation. This meter can be calculating the transformer or the line compensation losses, and can be added there and deducted from the energy. So you can enable that from here by choosing if it's for FE only or CU only. So this is like, or both of them. And once it's enabled, you have to go to the TLC calculator. To do this, you have to get that information for the transformer and the line, and that should be given by the data sheets of that transformer. So you have to input these values, and after inputting here or entering all the data, you will get the values you have to use at this one here. The cold load pickup, this is a function that if you are using the demand and for big industrials and maybe big customers loads, when you have the power shut down and you want to give a time before start to calculating the demand, because after the shutdown there would be the high peak at the startup. So you can give that time when after the shutdown to not be calculating the demand during that time. So you can set that for 1 or 2 minutes. So after the shutdown for 2 minutes, the demand would not be calculated. And then we have the pulse accumulation, and this is where we can set the 8 pulses and all the aggregators for the meter. And the last one is the time of use, where we can enable it from here. Of course, like everything we are doing here on the profile, we are doing on the software. So at the end of changing everything here, we have to hit update device. And once we hit update device, because I did change the CT ratio, so it's telling me that the energy will be reset, and I can hit yes if I want to continue. And it's telling me that do you want to continue because there's a module setting are corrected here. It's okay. And when you do that, it will give you the option to retrieve the logs, because we did that energy and CT settings change. So the logs would be reset. So before resetting the logs, it gives you the option if you want to retrieve these logs. And then continue. And this message here is telling us that if you don't want to change these settings, you can check these boxes. So if, for example, if you don't want to change the meter designation or the network, you can check these boxes and that setting will not be changed. This is like because the profile can be saved, so you can have one profile used for multiple meters. You want to make sure not to give the same communication settings and the meter name for more than one meter. It's uploading now the new settings to the meter. And it tells us that the logs had been reset. And going back to the device profile after updating the new settings, you can make sure by going to the general settings and see that the CT ratio is 800:5 now. So that's all about the basic programming here on the profile. On the next topic here, we would cover the polling screens and the reset of the meter. To do that, I would be connecting to another meter to have a real-time data. So I would use one of our demo meters in the office. Okay, after connected here, we would start with the polling screen here. So on the polling screen, we would be looking at voltages, currents, and power reading. As you can see, this is the voltages line to neutral and line to line, and the currents there, frequency, and the power readings. And we have the option also to view the waveform for the voltages, and we can choose any of the other voltages or the current. And we have the option to choose between spectrum and waveform. The next one would be the energy. This is where we can see all the energy readings. So as you can see, we have the delivered watt hour, the received watt hour, the VAR hours, and the VA hours. We have also the option to go to energy here, where we can see the energy on primary and on secondary, which before multiplying by the CT and the PT ratios. And we have also the accumulated demand and the different kind of energy readings, the I and V square T, the Q hour, all the energy readings from here. The next one would be the harmonics. And as you can see, we can look at all these harmonics readings up to 127th order. And also we can see the total harmonic distortion. And we can also have the option to do a spectrum or waveform if there is an harmonics there. Then we have the phasor. This is a nice function to help if there is any wiring issue and we need to troubleshoot that. So the phasor diagram can tell us what's the wrong exactly with the wiring. When we're looking at the phasor, we are looking for something similar to this. We have the three voltages, 120 degree apart, and we have the current of each phase like lagging or leading the current by a small angle. This meter is on the lab, and that's why you can see it has a very good power factor, which is 1, and the current and the voltage, they are on phase. In real life, we would be looking at a small angle between the voltage and the current. But if it's something different than that, then we can define what's the wrong with the wiring, if it's a reverse polarity, if it's across phases, and how to fix that. The flicker, this meter has the ability to also give you the short term and the long term for the flicker, and you can see that from here. The device status, this is the same window we got when we connect with the meter, which is popping up. It's the same device status window. And we have also the alarms. And this is based on how we set the alarm on the profile. Like for example, this meter has the voltage and had been set to be if it's above 144 and below 96. So you can see that the voltage is always 120, so it's in the limit. So that's why we have the green here. While the current here is set for above 6 and below 4. So you can see that the limit 2 is hit, and that's why we got in red. Also in tools, we can go to retrieve the device time from here. And if the device or the date is not correct, we can go to tools again and set device time. All what you have to do is just make sure that your time here is correct in your PC and use the PC time and hit send, and that would send the date and the time to the meter. Under the tools also, we can do a firmware update. And from the firmware update, we have to browse and choose the firmware file and hit start. And after updating the firmware, we have to reset the meter. We can also reset the energy accumulators and some other tabs also from here, reset device information. So we have the option to reset all the logs, or we can choose 1 or 2, or which log we want to reset. And we have also the option to reset the energy accumulators from here, reset our I2T and V2T counters. The max, minimum, and demand, and the time of use registers also. So we just have to check the boxes here and hit reset. The security under the tools, also you can enable the security. As you can see that when I connected this meter, it didn't ask for any password because the security had been disabled. But we can enable it from here, and it will ask you if you want to sure, are you sure you want to enable the security? And I will give it the password very quick. So once we enable the security, you would have the option to add users with different levels of security. So you can have a user one where you can give a username and password, and you can choose the role for that one. Like, is it 1, 2, and 3, and 4? And that would give him different kind of features or different kind of privilege. So like you can give user one for some kind of users, which can be just reading the meters, comparing to user two, who can be configuring the meter and updating the device profile of the meter. On the real-time pull also, we can also pull more some kind of readings from the meter, like similar to the polling and the energy screens here. We have the real-time pull where we can have the instance polling, the different kinds of reading, the revenue and energy demand polling. So you can choose all these type of real-time data. I think that's all for today. Thank you for joining again.